Hi everyone, welcome back to another video, and I'm going to be running this series almost concurrently with the Medicine in Folklore series, specifically as a review for people who want to go back and revisit the scientific method, or for people who aren't as familiar with statistics. This is the first of many videos talking about statistics, specifically about hypothesis testing and how we scientifically evaluate truth claims. So I know a lot of people in the community study philosophy or they study logic, and those are some great methods for evaluating ethical claims, evaluating supernatural claims, evaluating philosophical claims, and it's an equally good method. They have different contexts. Of course, I come from a scientific background, so I'm going to be covering methods of scientific demonstration of truth and of causality. So definitely worth looking at both sides of the coin. I think these are just different perspectives to approach similar issues, and they each have their benefits and their disadvantages as well. But something that I really like about the scientific method and statistics is that it's not as subjective as a lot of things in philosophy may be. Philosophy has some standards of criteria as well. They have syllogism, they have the laws of logic, and those are great. You tend to get into the weeds more with definitions and that kind of thing with philosophical arguing, when in science, a lot of these definitions are very standard, and I can approach something with mathematical calculations and reach whether or not it is significant or not. And it does take some more work on the front end, being able to understand and put together the data to calculate out your statistics, and then to evaluate your study design, figure out sources of error. But once you go through that work in the beginning, it's pretty easy to then approach conversation and say, here's the data, here's how I looked at it, here's how I know that we could reject the null hypothesis, or if we needed to keep the null hypothesis. So I really like this way of looking at it. I think it's beneficial to understand statistics and how we test hypotheses, and can also help you understand study design and how we could use one study to then look to the future to see how we could apply it to later studies and the significance of the conclusions that we reached. So this is an introductory video about the null hypothesis and the alternative hypothesis. So looking at the screen here, if we have a question that we are investigating, of course, anytime you're about to start a study, you want to have some kind of question, and this could be anything that we're looking at. Does smoking cause cancer? Does ivermectin cure COVID? These are all great questions that we could investigate. And we need to make sure that we are designing our study appropriately and understand what exactly is this hypothesis that we are evaluating. So the first term we're going to cover is the null hypothesis, and this is our assumption, also called H0. And this is assuming that there is no significant difference between specified populations. So if we have a question of whether or not smoking causes lung cancer, the null hypothesis would say that there is no statistically significant difference between the smoking population and the non-smoking population, and that if any difference were discovered, that difference is due to coincidence or error. So just because there might be a difference, let's say we had a 95% difference in the averages of a group of people who all watched Star Trek, let's say people who watched 90 hours of Star Trek or more happened to be more likely, 90% more likely to enjoy chocolate chip cookies than people who did not watch 90 hours of Star Trek or more. So that might be a difference. So you got a 95% difference in the enjoyment of chocolate chip cookies in the Star Trek group versus the non-Star Trek group. But you can already think about the fact that that is most likely a coincidence, or it could be error. We don't have a way yet of demonstrating that that is actually a causal relationship. So just because there is a difference does not mean that it is significant or that we can make any conclusions based on that. So the null hypothesis is saying that no significant difference, keyword significant, difference exists between the specified populations, or that any difference is due to coincidence or error. So we go into this as the assumption. But what we're trying to evaluate is if there is a difference. So this would be the alternative hypothesis, or HA. So the alternative hypothesis says that there is a significant difference between specified populations. So this would be saying if there is a difference between smokers and non-smokers and prevalence of lung cancer, but also that this difference is significant compared to like the any other variables that could be involved. There is a relationship that is demonstrated between these variables that we are studying. So when we go into evaluating these claims, we are going to assume the null hypothesis. We always go into it assuming that no difference exists. So think about this. Like if you are on trial, it is often said that you are innocent until proven guilty, and you need beyond a reasonable doubt level of evidence to convince somebody that they are guilty. So the null hypothesis is basically saying that the population is not guilty of having a significant difference. That's a weird way of putting it, but this is the assumption. We are assuming that there's no significant difference until it can be demonstrated statistically that there is a significant difference. So how we would phrase this is, if we were to demonstrate that there is a significant difference, we would reject the null. So either we accept the null or we reject the null. Those are the two possibilities that we can reach. And something really important about the null, so we accept it or we reject it, but if we reject the null, the only thing that we have demonstrated thus far is that there is a difference and that the difference is significant. We did not demonstrate what direction it was significant. So even if I found a difference that smokers had higher incidence and prevalence of lung cancer than non-smokers, that in itself does not necessarily tell me that there's an increased risk. There could be a decreased risk, because that would still be a significant difference. But all we proved was that there was a difference. It does not say what that difference means, and we would need to do more stats, more math to figure that out, and we will go into all of that kind of thing of what happens when you reject the null and what happens when you do not reject the null. So let's do a little example here. So I have a question. The question is, does smoking cause lung cancer? So we need to frame this as a hypothesis. So if we were to phrase this as a null, so the H naught or the null is when the so mu, the symbol here mu, is for the population mean or the population average. So if we have the null, if the null is true, then the population average of the experimental group, so the smoking group, is equal to the population average of the non-smoking group. So these are equal. And this is saying that there is no significant difference between smokers and non-smokers. So that would be the null. This is what we're walking into the study assuming. So then what would the alternative hypothesis be in this case? The alternative hypothesis, HA, would be simply saying that the population mean of the experimental group is not equal to the population mean of the control group. So there is a difference between the smokers and non-smokers. There is a difference. But notice here, this is not saying what the difference is. It is just saying that they are not equal. So this could mean either that the population mean of the experimental group is greater than the mean of the control group, or that it is less than the mean of the control group. So both of these, if we demonstrate either one of these to be significant, both of them would reject the null. So if I did a study that showed that the smoking group had a lower incidence or prevalence of lung cancer compared to the control group, and I proved that that was a significant difference, that would still reject the null, but that would not demonstrate that smoking caused an increase. That would demonstrate the opposite. So both of these reject the null, but they could mean very different things. So how then, if both of these reject the null, how do we reject the null? And where do we go from there once we have rejected the null? And that's math, and we're going to get into that in later videos. There are certain tests that we will conduct to demonstrate significant difference or not, and that we can use to show what that difference is. So I hope that you enjoyed this little video about stats, and we will cover more of this in the future, talking about p-values, z-scores, t-scores, all that fun jazz. Thanks for joining me, and I will see you all in the next one.